Okay, let's do a chi-square test on a two-way table here on the graphing calculator. So here we have some data on a survey. They asked the adults, what do you think about handguns? We got some yeses and nos. But in the course of doing the survey, we also asked other questions, one of which was, what's your level of education? This is actually pretty common in polling. So the results are broken down by the response to the question, but also then by the level of education. Do we have significant evidence that education level and opinion on handguns are associated? All right, so two clues here that we're doing a chi-squared test for association. One, they tell us right here the word associated shows up. But two, the bigger one, this is just from one sample. We took two measurements. What's your opinion on the question? And also, what's your level of education? So from this one sample, two measurements, that's a chi-squared test of association. So our null hypothesis going to be that there is no association between opinion and education level. The alternative, yes, there is. It's really as simple as that. Significance level is not given, so we're going to choose 5%. Now the conditions check. We are told this is a random sample. 11, 9, 6. If we put a 0 in the end, there's at least that many adults, so our 10% condition's okay. Now for the expected counts. Don't do these by hand. You can do row total times column total divided by grand total, 10 times? It's just not worth it. Let's instead use the calculator, and specifically, we're going to be using the matrix part of your calculator. And I'm hoping here that I'm going to make it big for a moment and then make it small again. All right. To get to your matrix, if you look above your inverse key, it says matrix in the same color as your second button. So calculator on, let's do matrix, and we need to edit. And I'm going to recommend just always edit matrix A. You need to give the dimensions, how many rows and how many columns. Now, don't include the totals here, just the two responses and the 5 education levels, so 2 by 5. And then we just have to type our numbers in. Now, it's going to go across the row when you press enter. So 58, 84, 59, and then I got to move here. Move back. And lastly, the 99. All right. It saves automatically. So when you've got that entered, go into stat, over to tests, and you'll notice there's no distinction between a test for homogeneity of proportions and a test for association because they're done the exact same way. So we want just the chi-squared test. It's going to ask us, all right, where's your matrix of observed counts? So that's one we just made. That's matrix A. For the expected, you don't have to make it. It's going to make it for you. It just needs to know where to store it. So just leave those as A and B. Never change. Let's do the calculation. Okay, now it's already done the test, but we haven't actually checked the expected counts yet. So let's do this. Let's go back and look at our expected counts in matrix B. Notice matrix B exists now. Choose edit, matrix B, and here they are. These are your expected counts. Now, you can write the whole number if you have space. I think I ended up rounding to the nearest 10th. And notice how I'm showing them. You just write them in parentheses. Now, in the actual calculation, don't ever use rounded numbers, but the calculator didn't. We're only rounding because there's not enough space to write the whole number. So just enough that we can see, yes, those are all above 5. So we're in good shape. Random sample, 10% condition, expected counts are all at least 5. Now, real quick, going to rerun the test just to get my important information. We didn't change anything. All right, so there's test statistic, degrees of freedom, and p-value that's below 5%, so we will end up rejecting the null hypothesis. There does appear to be an association. And quite frankly, that wasn't obvious, at least not to me, from the data because, I mean, most of these are pretty close. The only one that really seemed to be different to my mind is this one right here. For whatever reason, the less than high school doesn't follow the same pattern and trend as the others do. There were more yeses there than there were nos, and that's definitely not the case in the other categories. So I think that's probably where we're getting the largest contributions to this chi-squared stat. Unfortunately, there isn't an easy way to see the contributions from the two-way table. Your calculator is just not set up to give you that information. So conclusion then, at the 5% significance level, yes, we do have convincing evidence that there is an association between education level and opinion on handguns. And then just looking at it anecdotally, I bet it's because largely of this group here, where the proportion seems to be switched in a significant fashion from the others. And there you go. That's how you can do your chi-squared test for two-way tables on your graphing calculator.